Here we'll go with the first one, and you can see, you'll note here that a lot of the problems that arise are from language. What a lot of people, dismiss as semantics or word salad, and that's when they run into trouble because they give these types of explanations, these types of descriptions, and that's why they misunderstand, how this universe works completely. And here's the first guy, and he says the following, he says, I took LSD. Terrible way to start a presentation, right? I took LSD, he says. People do give off vibes, you can feel them hit you. Like, when you are thinking of someone and suddenly the phone rings and you know who it is and it's them. See, the problem here, they talk about knowing, they know. And, there's been a lot of tests out there that shows you can't consistently know, these kinds of things. You think it's someone and maybe it's someone else. And so there's a lot of that as well. And then he continues, says, if consciousness is a thing, then draw it. Yeah, obviously. If it's a thing, you should be able to draw it. Okay? But consciousness is not a thing, so obviously consciousness is something, is a concept, and therefore you cannot draw concepts. Okay, so yeah. Can you see light? He says. And I had to put in there the mediator of light, because that's what he's really referring to. He's not referring to light itself, but what is the mediator of light? Okay, so the question is it a bunch of particles running in a straight line? Is it a rope? What is light? Is it a wave? These are the questions. And so I had to put in there the mediator of light. That's what we cannot see. It says, no, you can only see what it's shining on. Absolutely not. We can see light, when light comes in directly into your eye, you can see it without any reflection. It just goes into the atoms of your eye. Okay, so yeah, you can see light. What we cannot see is the mediator of light. And again, it shows how these people, just brush over the language, and they don't. For them, it's all the same. They've got a muddle in their head, and just sound goes through one ear and comes out the other because they don't, process it in between. And they can't understand the differences now, okay? Especially the small differences there, right? It's like physical. Can you hold it in your hand? Well, light is physical, and the criterion that he's using, holding, that's the wrong criterion. That's the problem. You cannot say that you're going to hold something, and that's why the thing is a thing, because you can hold it, because you can touch it, or you can see it. That's where the problem is. No, physical means that it has shape. That's what physical means. It's a synonym of object. It's a synonym of thing. It's a synonym of body, substance. All those are the same words in physics. You either have that which has shape or that which doesn't. It's a black or white type of issue. If all words in the dictionary can be divided into those two categories. They either have shape or they don't. So God, for example, he has to belong to one of those. You have to tell us what your God is. Is God a thing? Does God have shape? Or is God a concept? And if God is a concept, well, obviously you cannot draw a concept. Like if God is love, God is intelligence, you cannot draw that. And therefore, that's what you're praying to. You're praying to a concept. Okay, so God has to be an object or a concept. Can't be both. Okay, and that is your God, the God that you're proposing. You can't say, well, I don't know what God looks like. I've never seen him. No, you're the guy proposing. We don't care if you saw him or not. We don't care if you saw space-time and all, any of those words. You have to tell us what you have going through your tiny little brain when you say God and you say space-time. You're the guy giving the presentation. Okay, so we can't guess what you have inside your brain. Okay, and so he says no. He says that light is not physical. It is, because the mediator of light has shape. So in that sense, light is physical. Why is light even in physics? Well, because it's physical. That's why. And then he just makes a statement out of the blue. He says, ether is light. And we've been discussing that, okay. We've been discussing that, the fact that, ether is not a thing. So you cannot say ether is light or light is ether. because we don't know what ether is yet. You haven't told us what ether is. Okay? You have to, if ether is a physical object, you have to draw it. If it's a concept, then we don't care. Light cannot be ether because light is not a concept in the sense that the mediator of light, whatever mediates light, is a concept. You can't have that. It's got to be an object. Otherwise, it cannot be a mediator, which is that which has shape. That's why you have to distinguish concepts from objects. It's a language issue. What most people dismiss as semantics, as word salad. We have to do 150% word salad before we do any theory, because that's what a theory is. A theory is word salad. That's what it is. Okay, and then it says it exists. He says light exists. Okay, it's not a physical object. He says it's ether, which is a concept, but it exists. So we have a concept that exists. He's saying that love exists. Okay, in physics. And no, love cannot exist because love is a concept. You can't say that a concept exists. And so he says it exists like your consciousness, like your imagination, like an infinite universe, yet taking up no space. And yeah, you can see why he's chasing his tail around, because he hasn't defined what exist means, what an object is. He doesn't even understand those two words. He just uses them. He says, is it physical? And he's thinking that it's got to do with holding, with touching. And then he said it exists like consciousness exists. And yeah, and consciousness does not exist, not in physics. We're talking about physics, okay, not ordinary speech. And yeah, consciousness, imagination do not exist. And so you can see how important language is, because it's easy to tear every argument this individual has with just language, because he hasn't done his study, he hasn't thought his theories, his ideas in rational terms, because he's using ordinary speech. He assumes that you know what all these words mean. And here we have another fellow, more or less along the same line. And he says, the poem says, is really addressing mereology, what things are made of. And he says, it's interesting that humans have some fairly simple tools capable of detecting electromagnetic phenomena. And no, you cannot detect phenomena because a phenomenon, right? Phenomena, they are not objects. Phenomena is something that's happening. So you cannot detect a concept, especially dynamic concepts like phenomena. And then he says, yet no one has ever detected your electromagnetic ropes. Yeah, and that's because the mediator of light is invisible and intangible. And, also of gravity, by the way, which is the same one. And yeah, you can go up there and very easily take, a pencil or whatever. Here, let me show you, for example, I'll give you an example here. We'll do it with a little spoon, okay? Here you have it, you have the spoon. You can't detect the mediator of gravity, whether above or below, whatever you're proposing. And you can't see it, you can't touch it. And you let go of it, and it falls to the floor. And so the question is there something here? And the answer is, there had better be something there that you cannot see or touch, for otherwise you're doing what the mathematicians call action at a distance. In other words, black magic. That's the scientific term for black magic and witchcraft. Yeah, you had better have some objects that are invisible or intangible. And whatever you propose as a mediator of light had better be invisible and intangible. So hopefully that's the case, okay? And here he continues, he says, according to Bill, right? But of course, detecting things isn't the proper way to do physics. It's not a question of detecting things. There are many things we cannot detect in this universe. Okay, we cannot detect the table that the Klingon has on the other side of the planet. And just because we cannot detect it, see it, touch it, or whatever, it doesn't mean that there is no table on the other side of the universe on his planet. And he says it absolutely exists because Bill drew a picture of it. No, this is not a question of drawing. It's a question that you have to define the word exist. And that's not the definition of exist that I have. Maybe it's the one he has. He thinks it's a question of drawing. If he can draw it, it exists. If not, it doesn't exist. No, it has nothing to do with drawing. And it has to do with whether it's an object and whether it has location. The first criterion for existence is that it has to be an object. It cannot be a concept like ether, for example. And then it's got to have location. Okay? And so you cannot say that the rope does not exist because you can draw it or you cannot draw it or whatever. It's got nothing to do with drawing. But if it is an object, there should be no reason for you not to be able to sketch it. And so he says that because of that, my theory, dwindles down to what his daughter does with crayons. Okay, yeah, and all because he hasn't defined his terms. He doesn't understand what an object is. It has nothing to do with detecting or touching or holding. And then he mistakes or defines the word exist, and he thinks it's got to do with drawing. And it's not the case. An object is not that which you can draw. An object is that which has shape. But if it has shape, you absolutely have no reason not to sketch it. Okay? Okay, we have our aetherist. He's been on the road with me for quite a while now, and he's trying to insist that his ether can show how light works, especially how light bends around corners. That's the issue. Okay, and so I told him the other day that this is what he was saying. Okay, and so I underlined the key words in his presentation, and he's talking about particles. And then he moves in and he starts talking about rays. So he says the rays do this and the rays do that. They reflect, etc., according to the law of reflection. He talks about rays. He never mentions particles again. And then he tries to show that if you put a needle instead of the slit experiment, right, the two slits, you put a needle there, we do get fringes anyways. And the question is, how do the particles turn the corner? And he doesn't talk about particles. He talks about, again, rays, and he uses the word light, but he never uses the word particles except to present them. He never uses them again. So his presentation is irrational because he's going to say that the particles can turn a corner like shown by the red lines, the red arrows, and create that spot, the Poisson spot. And no, you can't do that with particles. Particles will bounce outwards as shown by the blue arrows. And he continues, it's not like he said it once, he said it twice just in case. Here he says, take the Poisson spot, experiment, the light makes a ring with striations. Why? Because light reflects off the sphere near and from the edge of the circumference. Yeah, it reflects off, meaning that it bounces outwards. It doesn't. The question is, how do you get it to go inwards? That's the question. You want it to go like the red arrows towards the spot, and that's not what a series of particles do. And I told him this already 2 or 3 times, but he still doesn't understand it. And then he goes in there and he talks about rays again. He brings the word ray, which there's no physical object called ray, not in physics at least. You cannot talk about rays because there's no such thing as a ray. I cannot bring to the presentation a ray and show it to the crowd. So he talks about inward reflected light rays. He doesn't talk about particles. And again, he mentions the word particle only once, then he never uses it again. And he starts talking about rays and light and who knows what. Okay? And so, yeah, that's the problem. The problem is he cannot explain to us in a rational manner how the particles bounce inwards. Okay? So he comes back and he went to consult the ChatGPT or one of those bots, I think. Right? And here he goes. He says the following. He says, for bgaede, who just can't fathom light being reflected or scattered inward to form Poisson spot with the sphere. Okay, directly taken from ChatGPT. Okay, so here it goes, folks. This is from the bot itself, the most intelligent bot in the universe, right? Okay, it says, minor surface, these are statements that I just got off all of what he wrote. He wrote a lot of stuff there. I just took the main statements. And he says the following. He says, light can be scattered in various directions. Minor surface imperfections can significantly alter the path of light. Great, okay. Light might enter the cracks and be scattered inwards. Okay, he says, this is from the bot, right? The bot says the light can come inwards. Light is more likely to reflect off the surface, right? When light travels parallel to the surface of a sphere and encounters surface imperfections, it can be scattered, including potentially inward. Again, inward. Only a limited number of random rays actually make it inward. Okay? Okay, this is what the bot told him. And so at no point do you see the word particle. All it says is that light can go inwards. And we have no problem with that. We know we verified, our experiences that light comes inwards and creates the fringes by having all this constructive and destructive interference between one ray of light, one segment of light, and another one. Okay, so somehow they create this pattern. Well, we need to know what light looks like, what the mediator looks like to produce that kind of pattern. Unless you identify light, you don't have a sense of what's happening there, how Mother Nature does this magic trick. And so this is the issue here, once again, okay? Can you explain that scattering of light, right? Especially the ones going in there towards the center of the fringes, of all those fringes there. When you go to the center, how do you do that with particles? How do particles go inwards, okay, and begin to create that pattern right behind the needle? In other words, the needle is in the way of the flashlight or the laser pointer, and the fringes in the center. And the question is, how does a series of particles turn the corner? And he has not explained that. He says, and neither does ChatGPT. ChatGPT only can tell you whatever the mathematicians fed into it. It cannot do anything else. And the mathematicians don't know how to do that. And so they just say, yeah, light does bounce inwards. Yeah, we know that light turns the corner. All you have to do is turn the light on in your kitchen, and you will see that if there's a wall there, the light will spread sideways as well. And so you don't have to, that is our experience. The question is, how do you do that with particles? That's the whole issue. And this fellow, after like 5 or 6, 7 times, he still hasn't understood the question. He doesn't understand. He's got to explain this with particles, which is what he proposes. He says that can be done with particles. And so far, I'm still waiting how a particle turns the corner when it hits the edge. And I showed him very clearly the other day, when you throw a rock against a tree, the side of a tree, it hits the edge of the tree, it will never bounce inwards. It will always bounce outwards. Okay? And so we need to ChatGPT or whoever, all the mathematicians on Earth, to tell us how their particles, their photons, bounce inwards. That's all they got to do. That's how easy it is. Okay, the mechanism for that to happen. Okay, and then the fellow talks about the law of reflection, like he understands something about that, Okay, anyways, that's what he's got to do. He's got to show us how the particles bounce inwards, right behind the tree. It hits the edge of the tree on the right-hand side of the tree, right, and it turns left. That's what we got to find out, what the mechanism for that is. Even ChatGPT doesn't know, so don't consult them again. Okay, and here you can see it again. I'm going to show this with particles. With the slit, you can, the way they've explained it in the past is that the particles bounce against the sill or the jamb or the frame, right, of the slit, and then bounce inwards. That's how they explain today. That's how Einstein and Bohr discussed it in 1926 at the Solvay conference. And so they were talking about bouncing, okay, about the little ball bouncing against the frame and coming inwards. Yeah, you can do it with that. We can all understand. We can throw a ball against the edge of a wall, and it'll bounce outwards in this case, right? Because it's really bouncing. If you look at that frame, the frame of the slit, the one on the left, the gray little line on the left, it really bounces outwards, okay? So even in that case, it's an outward striking ball, right? It doesn't strike the edge and go inwards. In other words, to the other side where you can see where it's going right now. And so this is the issue. You cannot explain this with particles. And again, this poor fellow doesn't understand that. And this is what they've got to explain. See, how the blue balls we can all understand. They all go outwards, okay? But the question is, how do you produce the red ones that go inwards? And again, I don't know how else to explain it to him what the problem is. And he still doesn't understand after several tries. So I don't know. He still has the ball in his court. And I hope he can make it bounce inwards when he throws it against the wall. And he, like if the wall's on his left and he throws it against the edge of the wall, I want that ball to turn the corner and go left as well. I don't want it to go right. Okay, so that's what he's got to do. If you can't explain that, he doesn't have a mechanism, and his ether goes down the drain because he thinks that ether is a bunch of particles, or he at least simulates them with particles. Then he denies it. He says he doesn't know what the particles of ether look like, and so on and so forth. Okay, one fellow says it right the way he's got to say it. He says, ether is not a thing, so it cannot be drawn. Absolutely. Finally, one aetherisk who accepts that ether is not a thing. But again, all these etherists, none of them, agree with each other. And so they all have different notions of the ether. So what can we do about that? First, we need for them to tell us what the ether is, just like the mathematicians need to tell us what space-time is. And then once we can get them all to agree to what the ether is, then maybe we can all understand what their theory is, how they're going to explain the mechanism. Okay, here we have another fellow, and he says, the following says, some wackos will tell you that the ether is basically the mind of God. And it's God thinking, bro, that makes up all the reality. But they never explain how. Exactly, they never do that. And mind is just the brain communicating with itself. If you are knocked out or dead, there is no mind happening. Yeah, that's why we remove the observer from science or physics. There are no observers. You have to show your theory objectively. You got to show whatever comes out of the screen is objective. That's the same for everybody. Now, whether you saw the same thing as your neighbor, that's subjective. But what comes out of the screen, out of the event, out of the phenomenon, is the same. Mother Nature only has one thing that happened. She doesn't have 10 different things. We all interpret different things. But Mother Nature, Father Universe, whoever, the devil, whoever you believe in, they can only do something once. Whatever happened, that happened in a given way. And that way is objective. What we interpret, what we saw, what we explain from that event, that's subjective. But that's why we remove the observer. We talk as if we were Mother Nature or Father Universe when we give the dissertation. Okay, we have to all talk in that sense, as if this is not what I believe in. Don't concentrate on belief. Concentrate on the mechanism that I've just shown you. Do you understand it? Is what's coming out of the screen, do you understand that? And don't try to judge it. Just please understand it first. Okay, and once you understand it, then you can criticize it because you understood it. But if you don't even understand what comes out of the screen, if you don't understand that objectivity, that objective mechanism, then you are in no position to criticize it. Okay, because you still have not understood it. Okay, here we have another fellow, and he says, the language of the universe is mathematical physics. Is mathematical, right? So, I'm sorry. Physics is spoken mathematically. Absolutely not. Okay, the universe followed mathematical laws way before any human minds. There are no such thing as mathematical laws. What we have in mathematics is descriptions, quantitative descriptions of something that happened. Okay, so we have speed, we have weight, length, whatever, so we have all these parameters. And Mother Nature doesn't understand any of that. Mother Nature out there has no numbers. All she does, and Father Universe, what they do every single moment of the day is move objects from one place to another, especially atoms, All these atoms are moving into a universe. There are no numbers out there, no relations. Mother Nature has no relations. All she has is atoms moving from location to location throughout the entire universe. That's all there is. It's a physical world. That's physics. Okay? And that's all she understands. Mother Nature, she never went to school. Okay? And the universe must have mind consciousness and to follow mathematical laws. So see how they extrapolate. They immediately say that there's a God out there. There's a consciousness out there that has to run the universe because obviously they made it that way, so it's mathematical. So that you have, the circumference is 3.14 times the diameter. So those relations are relations we discovered, and we put numbers to them. Mother Nature, she doesn't even have circles. Okay, so she doesn't calculate volumes and areas. She doesn't do any of that. She never went to school. It's mathematicians who do all that stuff. We learn mathematics from nature, universe. Yeah, you learned it by measuring and so on. And it's got nothing to do with physics, so it doesn't really matter, right? And believing that you can practice physics without math is delusional. For that, you have to define what physics is, and obviously define math as well. And then, yeah, you can tell whether math has anything to do with physics. I mean, if I just want to explain why the spoon falls to the floor, right? Why do I need any math? I don't need to know how fast it came down. I don't need to know what the size or the weight of the spoon is. I don't need to know any of that. All I need to know is what physical mechanism caused the spoon to fall downwards and not upwards. That's all I need to know. I don't need any math for that. Okay, that's the issue. Okay, and then one fellow says, talking about the ropes, he says, I know what happens with your ropes. They are contracting between each other, crushing themselves. Therefore, yeah, they are pulling with all their might on each other this way and that way, I guess he meant. And he says, because if everything is made of threads, the way threads pull would be by the atom thread ball. Contracting within itself, this makes the pull force happen. Okay, yeah, it's not really a contracting issue, but let's continue here. It says, atoms must therefore kind of like miniature suns, you know. Suns also crush the material they are made of within themselves at the core, where there is a lot of heavy pressure happening. Yeah, there you have there's this pressure going inwards, and again, the way we explain that is that all atoms are physically connected to each other, and so they tend to go towards the place where you have most density. You know, so you have this pull force from every direction. That's why everything in the universe, most everything, is roundish, spherical. Okay. And this is how they generate so much gravity. Well, I just want to clarify that what our mechanism, the one we propose here is, and here you have it, okay, you have the astronaut falling to Earth. There's no crushing of the atoms. There's no really pulling on the ropes. What you have here really is that the astronaut, as he approaches the Earth, every atom of his body, right, is tied to every atom of the Earth. And so as he falls downwards, what you have is the ropes act independently. They're not on the same axis. And obviously, the farther the astronaut is from Earth, you can see here the ropes are closer together. Okay, so they get spread apart as he approaches the Earth. That's the mechanism we propose. That's for gravity. Okay. So again, it's a question when an object like, say, the moon, let's say you were to pull the moon farther away from the Earth, right? All those ropes, you know, they come together and form a single coaxial. And as the moon approaches the Earth, all those ropes separate. They're not on the same axis. And the closer they get, the moon gets to the Earth, the faster it goes. That's your acceleration of gravity. Okay, so there's really no pressure or any of those things. It's just the ropes, you know, either fanning outwards or coming together and forming a single coaxial. That's the mechanism. Very simple mechanism. Again, Mother Nature's not complicated as far as physics is concerned. Math is a separate story, okay? Different story. One fellow says how the rope model explains and provides a mechanism for the radioactive decay of various atoms. Okay, and so what I have here is just very quickly, I pulled that out of one of my videos. You can watch it. It's video, I think, number 30, neutron. So you can watch the video there if you can find it. Number 30, neutron. What is a neutron or something like that? And I'm just going to show you a piece of that. Okay, and here, just watch closely, and it'll give you an idea how radioactivity might work, the theory that we propose. Here it is.
A neutron is a crossroads of electromagnetic ropes extending from all atoms to all others. Heavier elements have balloons encapsulating smaller electron balloons and neutrons. It is inside stars like our sun where chemical elements are manufactured. There, countless atoms and neutrons are packed closely together. As atoms are compressed, the electron shells merge and form bigger balloons. These larger volumes necessarily incorporate more neutrons. For instance, when the electron shell of hydrogen expands, it incorporates an adjacent neutron and becomes deuterium. If the shell expands again, it now incorporates a second neutron and becomes tritium. The reason tritium is unstable and radioactive is that the balloon is stretched to the limit. It wishes nothing better than to contract to a lower energy level, to a more manageable size by expelling a neutron. Similarly, uranium is radioactive and unstable because it has 92 protons and 146 neutrons, 238 nuclides compressed into a volume no larger than sodium, which only has 23. Therefore, to invoke the favorite word of mathematics again, the rope hypothesis predicts that larger electron shell volumes will necessarily incorporate more neutrons. The larger the electron balloon, the more neutrons it can incorporate within this larger volume. And the more the outer shell is stretched, the more unstable and radioactive an atom will tend to be. It will attempt to expel nuclides.
Okay, so that gives you an idea of the theory that we propose based on a rope model of the atom of how radioactivity might work. Maybe someone more intelligent can come up with a better mechanism, okay? That's one we propose. And so this fellow continues, he says, how does the rope best explain relative stability of certain atoms versus others? Well, again, the best way is to look at the structure here, in this case, of the proton. I'll show the atom later on in another question. But here you can see what the proton that we propose looks like. It looks like a bunch of threads crisscrossing in a center. We call the proton star. And then you have the 2D version, the 3D version of the same thing. And so that kind of explains, I guess, part of what he's asking. Here's the other question that he asked for that. Let me put that back up there. It says, would I be correct in assuming that the number of interacting threads within the proton star, as you referred to, is what determines one atom's so-called atomic weight versus another? And so the only thing I want to clarify there is that all protons have to have the same size in the universe. In other words, protons cannot be different from each other because they're made out of the threads of every atom in the universe. Now, there could be a possibility that that atoms which are at the edge of the universe, right, might have more threads coming from one direction than from the other, okay? That's very likely, but we're not there. We're not at the edge of the universe. And so we would have to travel there and measure some values of atoms and protons and what have you over there to find out if the atoms at the edge of the universe look like the ones that are closer to the sun. And obviously with so much matter out there, that's something we will probably never know. Okay, so that's the issue. And then again, it shows why the atom is pretty much stable because you have all these threads coming from every atom in the universe. They form the proton star, and then the red one, the one that encapsulates that's the electron shell, and that's made out of every thread coming from every atom in the universe. And so that gives you an idea why an atom is relatively stable, okay? And as far as the instability that he talks about, the fact that you've got some atoms which are radioactive and they're not stable, like, you can have uranium turn into radon, and it just, or into lead, in fact, which is not radioactive. And, you can get uranium, give it enough time, it'll turn into lead because, again, uranium is radioactive. It loses all that radioactivity, meaning loses all those neutrons that it can't hold within that bag, and eventually it becomes like lead, which is a smaller atom. And that's the best explanation we have for that. Okay, another fellow says, is light one-dimensional? And no, all of that is 3D. Everything that you see there, the rope, each thread that forms the rope twines around it, coils around it, looks like DNA, exactly like DNA. Maybe that's where DNA got its shape. It's, kind of weird that DNA does look like a rope, and no, everything, the thread, the rope, the atoms, they're all 3D. There's nothing 1D or 2D in the universe, and much less in physics or in thread theory, okay, or the rope hypothesis. Okay, and finally one fellow says, so you debunked the Big Bang. Well, we don't debunk in physics, okay? Debunk, skepticism has all to do with belief. If you don't believe, well, then you've debunked it in your mind. Doesn't mean that your neighbor debunked it in his mind, okay? That's one issue. The other one is skepticism, again, is not science. Skepticism means, well, either that you don't understand it or you don't believe that that's how the universe works, what you just heard, okay? Okay, so you don't believe it? No problem. The important thing is, in physics, is to understand. Do you understand what the fellow is proposing? If you understood it, that's the end of science. Whether you debunk, whether you, believe, it's just an opinion, and that's religion. So there's no debunking in science. Okay? Debunking just means you disagree with that, or you don't think that that's the way the universe runs. That's all you're saying. Okay? Does that mean the universe had no beginning? How is that possible? Absolutely. We say that it's impossible for the universe to have a beginning. Okay? You cannot have true, genuine creation. Creation, you can create ideas. You cannot create things. Okay? You can turn wood into table. That you can do. But the wood was there already. You didn't create the wood. You didn't create the atoms that make up the wood. None of that can happen. Okay? The atoms were there. The wood was there. And all you did was create a table with those elements. Okay? So let's put the word creation in its proper context. You can create concepts. You cannot create objects. And here we even put God in there. Okay? You want God? No problem. So God now is going to start off the universe, okay? What he has is, I guess, nothing in his first frame, so I drew it black because space is nothing, and I don't think God can create nothing. I mean, that's very easy to create. The question is to create something, okay? And so here we have absolutely nothing in the first frame, and what this fellow is suggesting is that, that the universe had a moment of creation where God creates something from nothing. In frame number 1, there's nothing, and suddenly in frame number 2, you have something. Well, no problem. I mean, if this is what your theory is, what your proposal is, no problem. We don't want to hear it from God. We want to hear it from you. What is the mechanism? What mechanism do you propose that turned nothing into something? And if you cannot come up with a mechanism, you have to go with a better proposal, which is that everything that we see out there, all atoms in the universe, were already there, and they're there forever. Okay, so the universe, matter, meaning matter, right, of the universe, not space, but matter, has always been there. Well, for that matter, space has always not been there because space is a concept. It's space is the where, and objects are the what. Okay, and so we have the where, what, where. And that's the definition of existence, by the way. It's what, where. Okay, object and location. So what is the object? The what? That's the object is the what, and the where is the location. And so the question is, can you create the object? You have only location. Suddenly you're going to have existence. You're going to have an object pop in from nothing, absolutely nothing. Please explain the mechanism. Tell me how you're going to do that. How do you conceptualize that? In fact, I'll bring God here. No problem. I'll bring him and sit him next to me. And I hope God can tell us how he went from nothing to something. What's the mechanism? How did he do that in his garage or whatever, in heaven? So no, you can't create something from nothing, and therefore you have to assume that something has always been around. Okay, unless you can come up with a mechanism.